In a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. All right, so it says in circle E, DH is perpendicular to FG. DH is a chord, FG is a radius. That means we can use that highlighted theorem there. Go ahead and throw in the 90-degree angle, and it bisects the chord, so go ahead and mark those congruent segments. All right, so I'm going to make up a problem where we'll use this theorem. Let's say that DH is equal to 38, NF equals 12, and let's find the radius. Okay, so a little tip for you with these problems, anytime you're given the measure of an entire chord, you don't need that whole chord, just divide that by 2, okay? We don't need those 38s. So this side is going to be equal to half of 38, which is 19. So each of those little sections will be 19. All right, NF is 12. I'm just labeling everything before we get started. And to do these problems, you are going to draw in the radius, all right? And we're drawing in that radius so that we create a right triangle. And anytime you're missing a side of a right triangle, you're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. Now, be careful with Pythagorean theorem and make sure you've got your legs in there correctly. The legs are A and B of the Pythagorean theorem. And as far as the triangle, the legs are the parts that make out the 90-degree angle. All right, so we're going to plug everything in there and get to solving. Now, this one's not that bad. When you plug everything in, there's not much really to do but to simplify and then take the square root of both sides. So for this problem, the radius is equal to 22.5. All right, let's do another one. And this one is going to be a bit more of a challenge than the previous one, but I believe that you guys can do it. Just be careful and make sure you understand what sides make out the legs of the right triangle and what side is the hypotenuse of the right triangle. All right, so let's say DH equals 8 and GN equals 2, and let's find the radius again. All right, I'm going to label my picture. And remember that tip I said way earlier, anytime it gives you the chord, you don't need that whole chord. Divide that joker by 2. So 8 divided by 2 is 4. So I'm going to label each of those little sections as 4. I'm also going to label GN with a 2. Now we're missing this part this time, so let's call it X and let's draw in our radius. Anytime you're missing a side, just give it a variable. Give it a letter. Okay, so let's see. We've got everything except the radius. However, we actually do have the radius measurement. We may not have written it on that picture when we drew in the radius. However, remember from earlier, FG is a radius, and the radius is this section. It's 2 plus x, right? So I'm going to put 2 plus x right there. All right, so now we're going to plug all this stuff into Pythagorean theorem so that we can solve for the radius. And remember, the legs are the sides that make out the right angle. Okay, we're going to have to FOIL this stuff, 2 plus x times 2 plus x. And when we FOIL that, here's what we're going to get. We'll FOIL and, combine like terms, all that good stuff. All right, so to solve this guy, I'm going to subtract x squared from both sides, which makes the x squares cancel out. Then we've got 16 equals 4 plus 4x. We're going to subtract a 4 from both sides and divide by 4. So x is 3, but that's not the answer because we needed to find the radius, right? Well, the radius is 2 plus x. So the radius is equal to 2 plus 3, which is 5. And that's it. So anytime you're missing a piece, just call it x and just move on from there.